Okay.
Alright, so this is my West Point bridge design.
Go ahead and take your mask off so I can get you on the phone.
So this is my design brief. The client company was engineeringme.com, and our target consumer would be like people driving. I was the lead engineer of this project. So our problem statement was that there's a gap in between two different cities, and traffic is beginning to become clustered, as there is only one way to get to that city, between those cities. A team of engineers led by Brett are needing to design a bridge capable of supporting large cars in order to get across the large river. This will then help with the flow of traffic and will fix many issues. However, the budget of this must stay as low as possible. Our design statement is that a bridge will need to be constructed with a minimal cost while still being able to function. And then criterion constraints. We want it as cheap as possible. The highest deck is 24 meters. The highest point of the bridge cannot go past 32.5 meters. And it must be capable of holding its own weight in the weight of a 480 kilonewton truck. No more than 50 joints and 120 members. Must have a flat reinforced concrete deck. The bridge deck must be 10 meters wide so it can fit 2 lanes of traffic. And any materials given can be used. So this is my bridge 1, and as you can see, I tried to make it as small as possible, which because it'd make it the cheapest. And because of my materials used, I used a lot of hollowed out materials, which was the cheapest, and a lot of trial and error. And then my bridge 2, I just kind of went overboard, but it has the most strong and constructive material, and I used like the most amount of joints and members as possible. So my design summary is, I started my design off by following the basic outline given, using the most expensive materials to hold it up. After figuring out the total cost of the bridge, I then decided to begin using different materials to make the bridge cheaper. I also figured out that excavating to the minimum of 4 meters would save money in the long run, as it would spend less on materials because I would need less. I started off by making 2 triangles on the outside, 2 squares next, and then an X shape in the middle to construct the basis of the bridge on the deck. I then tested and realized that it couldn't hold up even using the strongest material. Therefore, I began adding members on the top of the bridge, which is when I tested that, and then it held up. And then I decided to make it cheaper and reducing the cost. So I ended up using hollowed out versions of the material, the cheapest material, and then increased the size to give it more strength. And then I kept doing this trial and error until my bridge held up with a total cost of around $204,000. So here's some of my cost calculations. My bridge 1, as you can see, shows the materials I used. I used high strength, low alloy steel, and then it's hollowed out. Same with quenched. And then and then that was my total cost of $204,000. And then my bridge 2, I used carbon steel bars basically the whole way through, and it ended up being around $1.2 million. So here's the animations, my bridge 2. And this is bridge number 1. So yeah, it's pushing it, but yeah. Alright, that's it.
Okay, nice job. $204,000. That's the price to beat. Good job.